Thanks, Mohit, and thanks to all of you for tuning in for the unveiling of the 2022 edition of the Cloud Performance Report. I'm Angelique Medina, Head of Internet Intelligence at ThousandEyes. For those of you familiar with our previous reports, you know we started our research journey back in 2018 when we released the first version of this report, which took a metrics-driven approach to understanding cloud network performance. We followed up in 2019 with an expanded edition that included new services and additional providers. Now, I think we can all appreciate the enormous changes the last few years have brought. As Mohit mentioned, we know that the adoption of cloud services has grown tremendously. And luckily, the data we've collected has grown tremendously as well. While our previous reports were based on 30-day snapshots of performance, our latest report is based on 3 years of continuous measurement collection, allowing us to understand cloud provider performance and behavior over time. And because we have so much data, we've decided to focus on the 3 major cloud providers: Amazon Web Services, Microsoft Azure, and Google Cloud. We'll also be focusing on each provider's standard network service, or default. We know that all 3 providers have a variety of network offerings, everything from cold potato routing to premium network service tiers. We'll be covering some of those other network offerings in a future report. For this report, we focused on 3 types of measurements: inter-region, which is measuring performance for traffic that is staying within the cloud provider's network, leveraging its backbone to go between different cloud regions. We'll also be looking at end-user performance from 72 global locations connecting to cloud regions in each provider. These measurements are helpful to understand performance for hybrid cloud deployments, say connecting an enterprise data center to cloud resources over the internet. And finally, inter-AZ measurements look at performance between different availability zones within cloud regions. Additionally, we examine multi-cloud connectivity for traffic moving between these cloud providers. Each of these types of measurements were implemented using network probes sent between 2 agents that we controlled. Unidirectional measurements, including latency, packet loss, and jitter, were computed by each target agent, and we also leveraged a customized form of TCP-based traceroute between the agents to enable path discovery. These probes were sent every 10 minutes for 3 years, from November of 2019 through the end of October 2022. As you can imagine, this yielded trillions of data points. Now, what emerged from all of this data were some of the findings we're going to talk about today, as well as some others that you'll only find by downloading the report. But across all of these findings, 3 themes kept emerging again and again. And we want to talk about those at the very beginning because it's going to help us frame all of the findings we're going to cover today. The first is that providers, just like all network operators, are not immune to performance issues. This may seem quite obvious to many of you, especially when we've seen many high-profile examples of cloud outages and their large-scale impact. But it's easy to classify those as rare events, and they are. But what we're talking about are the day-to-day or systemic instances of degraded or problematic performance, things that can impact any network. It's important to remind ourselves that cloud networks are networks just like any other, in the sense that they run on physical infrastructure. They may run into hardware issues or software issues, capacity issues, scale issues. They're subject to the laws of physics, and they are run by people just like enterprise networks. And similar to enterprise networks, they need to make decisions and manage different priorities when it comes to managing their networks. Our findings will cover a few examples of how these preferences and priorities can affect their customers. And finally, what we've seen again and again is that when it comes to the cloud, the only constant is change. I think we're all interested to see what's changed, what stayed the same, and what we can learn from the last 3 years. So let's dive into it. And again, we're only going to cover some of our findings. Be sure to download the report to learn more. So let's start with cloud connectivity architectures. As Mohit mentioned in our previous reports, we called out the different approaches that cloud providers have in getting users to their services. Now, of course, there are other options and service tiers that may differ from this, but each provider has a standard default approach, which is either internet-centric, where user traffic will spend more time on the internet, and backbone-centric, where traffic will enter the cloud provider's backbone more quickly, typically within just a few hops. This is Google's default approach. They announce routes to their cloud regions from their extensive network edge, so users connecting to a particular cloud region, wherever it is in the world, will ride Google's backbone to get there. This is the same as what we found in our previous reports, so GCP's approach continues to favor the use of its own backbone versus the internet. You can see this here, where a user in India connecting to GCP's US West 2 region in Los Angeles is entering Google's backbone locally in India. This is the same approach that Azure takes by default, and we can see here that traffic from India destined for the US West region in Santa Clara enters Microsoft's backbone very close to the user. So user traffic sees minimal time on the internet and is otherwise within Microsoft's network. This is a very different approach than AWS. AWS by default leverages the internet more than its peers. We can see that traffic coming from that same location in India is going over the internet and doesn't reach Amazon's backbone till it is closer to the destination region in San Jose. AWS does this by announcing routes to its cloud region closer to where they are located, so users will spend more time on the internet. Now, depending on where a user is located, that may be trivial. For example, if I'm in San Francisco, my traffic's going to get into Amazon's network pretty quickly because San Jose is very close by. If I'm connecting from, say, Johannesburg, my traffic must spend quite a lot of time on the internet. Here's another example of that same location connecting to AWS's London region. And again, we see the same behavior, where traffic will get routed through ISP and transit providers before connecting into Amazon's network. This is the same behavior we saw in our last reports. But what's different now is that we're seeing evidence that Amazon is making greater use of its backbone. For example, we can see here that traffic from Dubai is entering AWS's network locally and using it to reach the US West 2 region in London. We've seen a number of examples of this, where users in some locations will connect to an AWS cloud region using the internet, and some will use AWS's backbone. Again, what we're looking at here is the default routing to cloud regions. This is not making use of AWS's Global Accelerator. One of the features of Global Accelerator is the ability to get into AWS's network rapidly. But here, we can see that even though we're not using this service, we still get into AWS's network within just a few hops, even though the London region isn't close by. Now, there are no assurances that this will always be the case. This could change at any time. But it is interesting that some traffic in some locations gets the benefit of a premium service, even though they are using standard routing, while other traffic in other locations would not get the same treatment. AWS has been evolving and expanding its network over the last few years, and it will be interesting to see if these types of exceptions will become more commonplace, where it seems they are making more use of their own backbone. Now, you might be wondering why this matters. Does it matter whether I use the internet or I ride the cloud backbone? There isn't really a straightforward answer to that. But what we have seen is that ISPs make up a greater share of outages and disruptions for the outages that we've tracked over the last few years relative to cloud providers. Now, that being said, we also know that cloud provider backbones can underperform. We saw this in our previous reports in 2018 and 2019, where we can see that traffic that was flowing between cloud regions in Southeast Asia and cloud regions in Europe within GCP's network were taking a suboptimal path, and that was introducing 3 to 3.5 times the latency of its peers in internet baselines. And this was also the case for traffic that was coming off of the internet from users in Europe destined to cloud regions hosted in Southeast Asia, such as Mumbai or Singapore. And the reason for that was that GCP, again, prefers to route users through its own backbone. In this case, that latency that it was introducing was quite a bit higher than it would have been if those users had used the internet to get to GCP destinations in Southeast Asia. So we can see again that the cloud provider backbone won't necessarily be the best option. Now, in this case, the reason why GCP had such suboptimal performance was because they didn't have a direct route between their Europe regions and between their Southeast Asia regions, as you can see here. Now, they did roll out a new route in 2019. They made that announcement at that time, but we didn't see the rollout of this route until early 2020. So you can see here, and this is for inter-region traffic that's flowing between Europe and Mumbai, that latency came down very dramatically starting in April, and by May, we can see that latency had dropped nearly 200, or in some cases more than 200 milliseconds, now bringing it in line with what we see with its peers. Now, what about traffic that was coming off of the internet? Well, that was a very different story. So we can see here that there wasn't a steep drop in latency. We can see a gradual decline in latency that took place starting in October of 2020. So this was some months after the initial rollout for inter-region traffic, and a very gradual decline that finally brought all users over to this new baseline in September of 2021. So very different stories. Inter-region traffic, a very quick rollout taking place over about 10 days versus traffic that was coming off of the internet taking nearly a year to roll out and finally reach optimal levels. So that's very interesting, something to consider in terms of how providers prioritize which types of traffic will be optimized first or will be at the head of the line for fixes. Now, the prioritization that GCP showed didn't stop there. We also saw that for traffic that was coming off of the internet, so end user traffic, there was a very different story depending on where users were located. So for example, if you were a user in Copenhagen or Prague, your traffic was seeing that newer, faster route much sooner. So starting in October, and going all the way through February of 2021, you would have been part of the first phase of this rollout. Now, if you were in other locations in Europe, like for example in Milan, you would have had to wait for this new route for, in some cases, nearly a year. So we can see here that starting in February of 2021, all the way going up to September of 2021, this was the final or the last stage of this rollout. So it's very interesting consideration for enterprises when they think about their cloud provider and they think about how they manage their network. You should understand that they also have preferences and priorities in how they roll out new services, in how they make optimizations. And that's something to be aware of because you want to make sure that your priorities and your business are aligned to those of your provider. Now, it was great to see GCP make this optimization, and we expect that cloud providers will always be working to improve performance for their customers. So is it safe to assume that cloud backbones are always improving? Well, if we look at mature market performance, we can see that performance has been consistent year over year for the last 4 years, which isn't a bad thing. Performance is very good for the US East region connecting to global regions, and at some point you're going to plateau since traffic is only ever going to go as fast as the speed of light. But we have seen improvements. For example, we can see that Azure optimized performance between its regions in Oceania and its other regions in the Asia-Pacific area. AWS also improved performance for Oceania. Here we can see that latency came down dramatically versus 2019. AWS made this optimization in January of 2020, as we can see here, where we see a huge drop in latency between Sydney and Singapore. That said, even when optimizations are in place, performance issues can still crop up, as we see here at 2 points in 2020, where latency significantly spiked. Looking more closely at that second spike, notice how it took place over just a couple of days when there appeared to be sustained performance issues. What's interesting about this period is that we noticed that GCP also experienced suboptimal performance for that same route between Sydney and Singapore at that exact period of time. While some providers have dedicated infrastructure, they also will typically use shared infrastructure, and just like any other network operator, have to contend with capacity and scale challenges. We can also see that performance can vary wildly, even after optimizations have been made. Here we can see that even though Azure made performance improvements between its Oceania and APJC regions, there were periods, in this case a number of months, where we see extremely high latency, increasing around 150 milliseconds before it eventually stabilized. Instances of these fairly extreme variations were more common than would be expected and illustrate how performance snapshots on their own don't tell the full story. What's true today won't necessarily be true tomorrow. Cloud provider networks are very dynamic. There really is no steady state in the cloud, so customers should expect the unexpected. Now, let's switch gears here and take a look at cloud provider performance as it relates to China users. For enterprises serving users in China, it can be really challenging to determine what the best options are when looking for where to host within a cloud provider. Unfortunately, all cloud providers pay a performance toll when traffic crosses the Great Firewall of China. You can see that traffic coming from China connecting to the Singapore region is significantly higher than traffic coming from other user locations. This packet loss is not something that we see between locations within China. Now, there are viable hosting options for serving users in China. For example, Azure Singapore region and AWS and Azure Tokyo regions. In comparing Azure Tokyo and Azure Hong Kong, performance is actually pretty similar. The same goes for Singapore versus Hong Kong. Hong Kong is still a good option in terms of performance, and in comparing mainland China and Hong Kong locations, we can see that Hong Kong is still outside the Great Firewall of China, as content that is inaccessible for China users is still available in Hong Kong. This is at least the case when connecting through global transit providers, though it's possible this could change at some point. Now, to recap some of the lessons from our findings, performance issues can impact any network operator, including cloud providers. Cloud providers will make decisions about how best to manage their networks, which may involve prioritizations and preferences that could impact you. And finally, there really is no steady state in the cloud. So what should you do about all of this? If you're a cloud customer, you should keep a few things in mind. First, you should understand your baseline, whether that's how your provider typically routes traffic or what normal performance should look like. Second, continuously track performance and conditions to ensure that you're aware of inevitable changes. And finally, use this data to continuously optimize. Now, what does it mean to continuously measure and monitor your cloud environment? To walk through some tangible examples of this, I'm going to turn things over to Group Product Manager Prab Singh.